Hey, welcome to day 7 of grinding Leetcode. Today is a good day because I just had breakfast this morning and I am energized and ready to go. God, I need to shave. I feel like the more chocolate milk I drink, the more pimple in my face appeared. Let's go. So this is a series of video where I grind a Leetcode. I try to do a Leetcode easy problem within 15 minutes. If I fail to do so, then I'm going to look at the solution and hopefully figure that out. So the best strategy so far is that for me is that if I look at the input and output and then trying to figure out what the code is doing, then I can easily figure out what I need to do. And then afterward, if I need some clarification, then I'll look at the description. So that's what I'm gonna do. Let's say the input is gonna be A and 12, B is 6, output is 4, explanation, the common factor of 12 and 6 are 1, 2, 3, and 6. Oh god, I don't like this. Input A equal to 25, B equal to 30. The common factor for 25 is 1 and 2. Or 1 and 5, so there's 2 of them. The common factor for that is 1 and 5. Okay. God, is this one of those like find a binary number or something? Okay, so I can iterate through from 1 to 12, right? And from 1 to 6 actually. From 1 to the smaller number. And then I can do 12 divided by 1. Is there a remainder? If not, then no. 12 divided by 6, is there remainder? 6 divided by 1, is there a remainder? No. Then go forward. And 12 divided by 2, is there a remainder? No. 12 divided by 3, is there a remainder? No. 12 divided by 6 by 4, is there a remainder? No. 6 divided by 4, there's a remainder, so you can't use that. So it's going to be like modulo by whatever I is, linear range. So this is going to be an O-N operation. I don't see how can be faster. I mean, there's probably a way to, it's like finding prime number thingy. I'm going to try to solve it that way first, and then I'm going to see if there's a better solution. Okay, I have exactly 10 minutes. Let's go. 4. So length is going to be... The length is how many times we're going to iterate through. And that's going to be equal to the minimum of A and B. B. Okay. So for I in range 1 to length. And that's what that's going to do is that's going to loop from 1 to up to length. Which is, let's print out length. Or might be, okay. None is not a valid integer. Oh, 6666666. Okay, so that's good. I gotta return something, so that's why. Res is equal to 0 initially. And in the end, we're going to return res or total. I think this is going to be a pretty easy problem. Unless there's some crazy optimization I have to do. So for I in range of 1 to length, we're going to iterate through and see if A divided by A modulo. If A modulo I equal to 0 and B modulo I equal to 0, then total plus equal to 1. And that's it. Let's see if that works. Output 1, expected 6. Okay. A modulo I is equal to 0 and B modulo, oh my goodness, modulo I. Output 3, expected 4. Okay. Okay. Expected 4. Let's go ahead and print out I every time it gets in here. Let's see what we have. One, two, three. But it never got to 6, didn't it? It never got to 6. Let's see if we can print out print out I every time again. I don't think we have to do like +1 here, I think. Length +1. Okay, yeah, that's why. It never got to 6, so we're gonna do length +1. And that should completely solve the problem for us. So, okay, of course it's not gonna be the fastest. Oh my god. Okay. Okay. That is doing the exact same thing. Pow. I know there's a math trick to this. So if both of them are, why don't I just divide them by 2 every time? Divide them by 2 until they get to, if I divide 6 by 2, that's 3. If I divide by 12 by 2, that's 6. And then yeah, I know there's some trick. If it's a 5 in the number, in one of the number, then you can do 5, right? There's some optimization to be done. I know for sure. If there's a 5, if it's a 25, if you can modulo it by 5, hang on a minute. It'd have to be a whole number to be modulo by 5. Return a number. No, in this case, if it's 30 and 60, then the common divisor is 30. Common factor. Hang on, let's look at, okay, I solved it already. So let's look at efficient Eleusian elucid algorithm. Eleusidian algorithm. Euclidean. Use the Eleusidian algorithm to write 2 in a linear combination of 120. To write 2 in the linear combination. What is? This is a better question. What is the Euclidean algorithm? Okay. Greatest common divisor. Right? What is the GCD? What is the GCD? Greatest common divisor. Okay, so that's, I mean, I can use the Euclidean algorithm to find the greatest common divisor, and then I can loop from 1 through that number to see if it, okay, from loop, and if they both even number, then I only need to loop over the even number. If they're odd number, then I only need to loop over the odd number. So that will speed up quite a lot. So doing this is a lot faster. But this is still O of n. So the downside is, yeah, I can see using the Euclidean algorithm. It's gonna save me some cycle. If it's up to like, if it's 2000 and 1000, that's a lot of cycle. So I can use the Euclidean algorithm to knock it down. Fine, okay. Online GCD finder. GCD calculator. Okay, let's do 100. Let's do 1000 and 2000. That's gotta be calculator GCD. Yeah, GCD is 1000. So the minimum is 1000. No, that wouldn't help me because that might help me a little bit, but not a whole lot. How about 50? How about 57? How about 57 and 57 and 2000? That's gonna be 1. Yeah. Yeah. So I could use the Euclidean algorithm to find the greatest common divisor, and then just iterate through that range. If it's an even number, then only iterate through the even number. If it's an odd number, then only iterate to the odd number. But for today's video, I'm tired, and I'm not going to do that. It's on the weekend too. I'll get back to it on Monday. So goodbye.